Today we're taking a look at section 2.4 on survey and cardinal numbers. In the survey problems, we have some words, some English words that have specific meanings that rely on set theory. And means the same thing as intersection, or means the same thing as union. Not means the same thing as complement, but means the same thing as and. It means intersection. So in doing survey problems, we have some steps that we go through, and we're trying to make this as easy as possible. We're going to first of all draw a Venn diagram with the appropriate number of sets. We'll begin with 2 sets and then we'll move on to 3 sets. Number 2, we label the sets so you can identify one from another. Number 3, we begin filling in the number of elements in the area of most intersections and work outwards. Be sure to subtract numbers already included in the diagram so as not to double the count. And then finally, we answer the questions we're given for the particular survey problems. And so we're starting out with a problem that deals with 2 sets. So I'm going to draw my universal set. And let's read the problem. It says a group of 50 art majors were asked to identify the color they would choose for a vase that they were making. Here are the results. 13 chose blue and red, 27 chose blue alone, and 21 chose red. Not necessarily alone. That may be what you think, but it may not necessarily mean alone. Okay, so we have blue and red. Alright, what we want to do is start in this region where the 2 intersect. How many chose blue and red? 13. Now what we have to realize is when we're given the number for blue, that includes these 13. See, here's a circle for blue. Let me see if I can find a blue highlighter. There's the circle for blue. So it contains the 13. That means we only need 14 more to make 27. Now when we go to the circle for red, and this is not quite red, but I'll use this to highlight it, we have 21. Well, we already have 13, so that means we need 8 more to make the 21. Now, we were told there were 50 in all. Do we have 50 people in this diagram? Well, let's add 14 plus 13 plus 8. 15. No, we only have 35, it looks like, in the diagram thus far. So I want to figure out how many are outside the circles. That's going to leave 15 to go outside the circles. That means they didn't choose blue or red. They chose some other color. Okay, now we refer to our diagram when we answer the questions. It says, how many art majors did not choose either red or blue? Well, that's the number we just calculated, 15. Alright, how many art majors chose exactly one of the 2 colors? Well, 14 chose blue alone, 8 chose red alone, and so that gives us 22. So that's how we want to do our Venn diagrams for the survey problems. Okay, now in example 2, it's a little more complicated. This time we're moving to a case where we have 3 sets. So I need a little more space. Draw my 3 circles for my 3 sets. Okay. It says a group of 150 students were asked to identify the sports that they participated in during the previous summer. Here are the results. 5 played golf, volleyball, and swim. So we have golf, volleyball, and swimming. Okay, 8 played golf and played volleyball, 10 played volleyball and swam, 9 played golf and swam, 21 played golf, 35 played volleyball, and 53 swam. So again, we want to start where we have the most intersection, which is right here. And let me straighten out my diagram a little bit so I can see where that region is. Okay, so we have 5 people that played all 3 sports. So we begin with that. Now we move to where we have just 2 overlapping. So now we're on golf and volleyball. Golf and volleyball. We'll do that one in red here, or purple, pinky purple. So we have a total of 8. We already have 5, so we need 3 more to make 8. Notice how I'm subtracting off, so we did that one. Okay, and our next one, let's go to green. 10 played volleyball and swam. Okay, so there's, whoops, didn't mean to go that way. Gotta redraw my circle. This is swimming. Got ahead of myself. Okay, so let's try that again. Got green. Volleyball and swimming is this little region right here. We already have 5 and we need 5 more. Okay, 9 played golf and swam. So let's see, we'll get the blue one. Golf and swimming. Well, we already have 5, so we need 4 more. Okay, now we go to the individual circles. 21 played golf. How many do we have in golf so far? We have 4 plus 3 plus 5. That would be 12. So we need 9 more to make 21. We have 35 played volleyball, so we're in the volleyball circle. We have 13. 35 minus 13 would be 22. Okay, and for swimming, that's this circle right here. See if I can close my little email there. We have what, 10, 14. So 53 minus 14 be 39. Okay, now we know we started with a group of 150. The question is, how many do we have in the diagram thus far? Alright, so we've got to add 9, 3, 22, 4, 5, 5, and 39. Okay, 12, 14, 18, 28, 37. Okay, I think we have 87 thus far. If I added those up right, 12, 14, 18, 28, 37, 6, 7, 8. Okay, so I'm going to subtract 10 minus 7, and then 14 minus 8 will give us 6, so that's 63 out there. Okay, now we've got our questions to answer. How many students did not participate in any of the sports? Okay, that's the 63 we just calculated. How many students played in exactly one of the sports? That's going to be the 9 plus the 22 plus the 39. I have to line them up so I can do them for 7. I'm getting 70 on that. How many students played exactly 2? Those are the ones 3, 4, and 5. 3 plus 4 plus 5. It's going to be 12. How many students did not swim? So we want all the numbers outside the swimming circle. 9, 3, 22, and 63. We don't want to forget that. 9, 3, and 22. Let me double check. 22, and then we don't want to forget the 63. So again, 63, 9 and 3 are 12, and 22, we're going to get 797, it looks like. How many students play golf or volleyball? So what we want to do is add up the numbers in the union of the golf and volleyball circles. So let's see, I'm going to add these number 10, that's 17 in the overlaps, and then 9 and 22, 18. So I have 48. Okay, so alright, now we have one more page. I was hitting the wrong thing. This is for the cardinal number formula, and this is one of those things that actually did not transfer. And so I'm going to go ahead and write it down. This is for the union of two sets, and I'm going to explain why this formula works. Oops, that should be a minus. Minus number in A intersect B. Okay, let's count the number of elements in A union B. Number in A union B, we would just simply add up all the numbers we have here. And so we're going to get 1321 elements are in A union B. But let's look at our formula. According to that, we want to take the number in A plus the number in B minus the number in A intersect B. So the number in A, notice, is 13. The number in B is 11. But what have we done when we did this? 13 and 11. We double counted the 3. So what we have to do is subtract off that number that's found in the intersection, which is the amount we double counted. So we're going to get 24 minus 3, which gives us 21. So the reason we have this part in here is to eliminate the double counting. We have to be careful not to double count when we're talking about the number in A union B. So that concludes this lecture. Your next step is to watch the sample problems.